Alright, so this video isn't going to be very long. I just wanted to make a quick note on what is in the notes that we got at the end of class on Thursday. And the only thing I'm going to go over is this part on the front side, just because I thought I might as well go over it. Even if it is pretty easy, it's just nice to go over it. So basically, um, there's a question. It's question 2, and it says find the inverse of each function below using the method from 1D. And 1D on that paper is just saying that you can find the inverse of a function by changing the values of x and y and then solving for y. And obviously, of course, um, in case a function starts with of x, f of x is just a more fancy way of saying y, pretty much. So you can just use y for that. And so it's easier for me to demonstrate it. It's easier for me to demonstrate it when I actually do it than talk about it. So basically, what it's saying is, if I wanted to find the inverse of this function, what I would have to do is switch y and x. So this would become x equals 2 times y minus 1 cubed. Let's see if I can get a better tool. I don't know. But basically, oh yeah, that's much better. Alright, so, but yeah, this is what you would do. And once you get here, you would just solve for y once you get here. So, what you would do first is get rid of this 2, because that's what you would do in most of these problems. You would get rid of something multiplying. So this would then become x over 2 is equal to y minus 1 cubed. And then we have to get rid of this cubed. So then all we have to do is do x over 2 to the cube root, and then that equals y minus 1. So then all we have to do is get rid of this 1, which would just be done by doing this. So this would be the cube root of x over 2 plus 1 equals y. And this would be the answer. So basically, all this is saying is that you should swap the places of x and y and then just solve for y, and that would give you the inverse function. Which, if you look at, or if you have looked at my last tutorial on finding inverse functions, this does, this does make sense as being the answer. And then this is, and getting rid of all of that. This right here, this is just another example that's a bit more complicated, but this is just like the same thing. So you just swap x and y, so that would turn into this. And then you just go about solving the problem as normal. So first, get rid of this 3, so this becomes x minus 3 equals the square root of y minus 2. And then we get rid of the square root, so this would be x minus 3 squared. And notice that I don't just put x minus 3 squared. This is a singular entity, and we are putting it squared because this is a square root, and in order to square both sides, we have to square root that, which cancels that out, but we have to consider this whole left side. So that would be in parentheses squared. And so this would be just equals y minus 2. And so then we have the 2, so then this would just be x minus 3 in parentheses squared plus 2 equals y. And you would think that we could stop there, and you could, but we can simplify this further. Going back to using our little square thingy, I don't really know what to call it, we can actually factor this out. So we can have x minus 3 and x minus 3, and this gives us x squared. This gives us negative 3x. This gives us negative 3x. And this gives us 9. So we could do x squared, and then we do negative 3x and negative 3x. That would equal negative 6x. And then we have 9 here, and we also have this plus 2. So 9 plus 2 would equal 11. And that would equal y. And this would be the simplest form. This would be simplifying it, so this would be the best answer. So that's really all there is to it. I just wanted to make this quick video, and that's it. Peace.